How long will it take for $1,000 to grow to $20,000 at 8% interest compounded monthly? So because the interest in this problem is compounded monthly, we know we're going to need to use our compound interest formula, which is A is equal to P times the quantity 1 plus R divided by N raised to the NT power, where N is the number of times the interest is compounded in 1 year. So if the interest is compounded monthly, we know that N is equal to 12. So we'll start with P. Our principal is how much money we're starting with, the initial amount. And we see right here that our initial amount is $1,000. So that means that our P is 1,000. And then on this problem, we're solving for how long it takes for this $1,000 to grow. So we're solving for time. So T is going to be the unknown in the problem. We're solving for time. Now remember, A is your accumulated value. In other words, it's your after amount. It's how much money you're going to have at the end of T years. And we want our account to grow to $20,000. So initially then, our setup would be $20,000 is equal to our initial amount of 1,000 times the quantity, 1 plus. Now remember, R is the interest rate, but you have to make sure that you have the interest rate converted to a decimal. So 8% interest is going to be 0.08 divided by 12, since the interest was compounded monthly. And then it's raised to the N times T power. So that would be 12 times T. And there's our unknown. Our unknown is T. So what we have right here is an exponential equation because the variable here contains the exponent. So to solve this exponential equation, we first need to isolate the exponential quantity. So we need to divide both sides by 1,000. Because the exponential quantity in this problem is the 1 plus 0.08 divided by 12 raised to the 12t. So that's why we're dividing by 1,000. So we'll end up with 20 is equal to the quantity 1 plus 0.08 divided by 12 raised to the 12t. Now we want to be as accurate as possible, so we should probably investigate with our calculator the value of 1 plus 0.08 divided by 12. So take out your calculator, pause of course the video if necessary, and let's find this value. So it turns out that this value is approximately 1.006. But you'll notice that it's not exactly this decimal. This continues on. So this is not an exact decimal. So if you wanted to use 1.006, then I would encourage you to use the store feature on your calculator and store this value. Or you could go ahead and use your graphing calculator to convert this decimal to a fraction, if it converts. And this one does. The exact value for this decimal is 151 divided by 150. So it is up to you whether you want to use the stored value or the exact value. For this example, I'll go ahead and use the exact value since it does convert to an exact fraction. So really I have 20 is equal to 151 divided by 150 raised to the 12t. So remember, this is an exponential equation. In other words, this is an exponential form. So then to get it out of exponential form, well, you have two options. You can rewrite it in its corresponding logarithmic form, or you could take the log of both sides. But my preference is always to rewrite the equation in log form. And to do this, remember, you always just begin with the base. The base will become the base in the logarithmic form. So when you convert this, you'll have log base 151 divided by 150 of 20 is equal to 12t. So to solve for time, then we would divide both sides by 12. But of course, we don't want to leave our answer like this. It'd be more beneficial to actually answer how long it takes, how many years, to get an estimate. So we need to go to our graphing calculators and input this logarithm. So if you're on the TI-84s, remember, you're able to enter other bases. So you'll use your shortcut menu and enter the logarithm exactly as we have it written here. If you are on a TI-83, or perhaps your TI-84 hasn't been updated, then remember, you're going to have to use your change of base formula to convert this logarithm into either a base 10 logarithm or a natural log. So just remember that your change of base formula says that when you have log base b of m, you can change that into any base that you want. If you chose base 10, it would be log of the argument divided by the log of the base. If you chose natural log, base e, then it would be the natural log of the argument divided by the natural log of the base. But you could choose any base that you want. So for those of you on the TI-83s, you would need to enter this as the log of 20, because 20 is the argument, divided by the log of the base, and the base is the 151, divided by 150. So you'd have to enter that in your calculator, and then you would take that result and divide by 12. So check that on your calculator. You should have approximately 37.57 years. Remember, time is always measured in years for these compound interest formulas. So even though the interest was compounded monthly, we were looking for how many years it's going to take for your investment to grow to $20,000, and that's about 37.57 years.